All right, Math 12A. We have finished your test. Most of you did fairly well on that. Yay. So that's done. We only have 2 chapters left and we have 6 weeks left of school. So let me just give you a quick overview of what I think that's going to look like. Chapter 8, I break up into 2 tests because there's quite a bit in it. It's not hard, I promise. It's probably easier. Well, it's definitely easier than like chapter 5 or something. But we're gonna do it in 2 tests. We're gonna break it apart. And then we have chapter 9, which is the personal finance chapter, which is the one I'm sad we don't get to do together. But that's okay, we'll make the best of it. So we're going to do sections 8.1 to 8.4 test, 8.5 and 8.6 test, chapter 9. There will be a project to do with chapter 9 that's going to involve you doing some research on different jobs and then doing up a budget based on that. And you'll have to do some research with that, by the way. There will be things you will need to look up. And we will probably do a couple of Zoom meetings during that because there's some things I like to get your feedback on when we do those. I like to get you a little bit more involved in those. Anyway, after that, obviously there's no exams unless something drastic changes. So what I will do is for the last probably couple of weeks of school, I will have a big assignment that will take the place of your exam, and it will cover everything we have done this semester, and that will factor in greatly into your final mark. It will be weighted pretty heavily. An exam is weighted pretty heavily, so that will be weighted fairly heavily. The good news is it has to be open book, right? I'm not going to sit beside you and watch you. So that's sort of where my thoughts are at this moment in time. Our lives seem to be ever changing right now. So if that changes, I'll let you know. But at this point, that's what that looks like. We're going to make the today relatively short. Just cause, why not? Section 8.1, we're only going to do one example out of this for today. So section 8.1 is connecting coordinate geometry. What they mean by coordinate geometry is an XY axis and points on that XY axis. Like if you had the point 3 and 4, you would go across 3 and up 4, right? So graphing on a Cartesian plane. And plane geometry. And plane geometry just means talking about squares and triangles and that kind of thing. You don't have to know theorems for this. So, in example 1, but you do have to, we are proving some things, but rather than using theorems, we're using math to prove it, okay? So it says verify that point A, which is -1 and 2, and point B, which is 3 and 0, and point C, which is 1 and -4, verify, meaning prove, meaning show, that those points are the vertices, and the word vertices just means corners, are the corners, or are the corners of a right triangle. Okay, so that's what part A says. So I'm going to draw it. You don't have to draw it, although I do find if you are at all visual, at all, even a little bit, it helps to draw it. So point A is -1 and 2. That's point A. point B is 3, 1, 2, 3, and 0. And point C is 1 and 1, 2, 3, 4. So that's point C. Okay, so that's the triangle. Now, what it wants us to verify is that these are the corners or the vertices of a right triangle. So what's a right triangle? A right triangle is one that has a 90-degree angle in it. So if it has a 90-degree angle in it, that means that two of those lines will be perpendicular to one another. Now, this is why I say drawing it helps. When I draw it, I can basically tell where I think that right angle is going to be. Because that doesn't look like a right angle to me, neither does that. But that could certainly be a right angle. Now, how do I know that that's a 90-degree angle? How do I know that those two lines are perpendicular to one another? One of the things that you've learned somewhere back there somewhere is that perpendicular lines have slopes that are negative reciprocals. I spelled that wrong. Reciprocals. Okay, reciprocals of one another. Negative reciprocals of one another simply means that if you find out that one slope is 3/4, the other slope is negative because this slope was positive. So if one slope was 3/4, the other slope would be negative 4/3. Opposite signs and flipped over. Those are negative reciprocals of one another. All right? So if I'm going to verify that this is that these two lines are perpendicular to one another, that this is a right angle, what I need to know is I need to find the slope of this line. Slope is always represented by the letter M. And I need to find the slope of this line. So I need to find the slope from A to B, and I need to find the slope from B to C. If this is where the right angle is, then these two slopes will be negative reciprocals of one another. So that brings me to what is the formula for slope. Again, you learned this in grade 10 for sure. I can't remember, I don't think we do it in grade 9. But slope is y2 minus y1 over x2 minus x1. That's the formula. It is the change in y divided by the change in x. And remember that slope is rise over run. That's why the y's are on top, because what goes up and down, what rises is the y-axis. So the y's always go on top, the x's always go on the bottom. So from A to B, if I do y2 minus y1 over x2 minus x1, A to B means I'm using this point and this point. And it doesn't matter which point you make 1 and which point you make 2. It doesn't make any difference. If I decide that this is my x1 and this is my y1, then this would be my x2 and this would be my y2 because I'm going from A to B. So y2 is 0 minus y1 is 2 over x2, which is 3, minus x1, which is negative 1. So I end up with negative 2 over 4, which reduces to negative 1/2. So the slope from A to B is negative 1/2. Now, I also need to find the slope from B to C. So from B to C, again, if this is my x2 and my y2, then I'll label this x1 and y1. Again, it doesn't really matter which one is which. So again, if the formula is y2 minus y1, my y2 is 0 minus my y1, which is -4, over x2, which is 3, minus x1, which is 1. So this is 0 minus -4, so this is 4 over 2, which reduces to 2 over 1. So notice they are opposite signs, and 1 over 2, if I flip it over, is 2 over 1. So I have just verified, I have just proven, I have just shown that these are right angle triangles because the slopes are negative reciprocals to one another. All right? So that's one formula that you need to know, is the slope formula, y2 minus y1 over x2 minus x1. So that was part A. Part B says, is this triangle ABC, is it an isosceles triangle? And don't just tell me yes or no, show me why your answer is what it is. Some of you who don't like to show work, if I say, is this an isosceles triangle, and you just put no, I'm not giving you anything for that. Even if you're right, I'm not giving you anything for that because that's called guessing. You have a 50-50 chance at that. You have to show me why. The whole point in this is why, all right? So there are 3 types of triangles, and we're going to talk about those briefly. There are 3 types of triangles. By the way, sorry, Mrs. Gautreaux crazy again. Remember, perpendicular lines have slopes that are negative reciprocals of one another. Parallel lines have equal slopes. Their slopes would be the same. If 2 lines are parallel, then the slopes are the same. Parallel lines, same slope, all right? But anyway, back to types of triangles. There are 3 types of triangles. There is an equilateral triangle. And that means all 3 sides are the same. They are all equal. The length of each side is the same. There is an isosceles, which I can't possibly spell. Isosceles triangle, and that is 2 sides are the same length. And then there is a scalene triangle in which no sides are the same length. Okay? So there are 3 types of triangles. There's the equilateral, where all 3 sides are the same length. There is the isosceles triangle where 2 sides are the same length. And there is the scalene where all 3 sides will be different lengths. So they say in this question, part B, says, is this an isosceles triangle? And remember, in an isosceles triangle, 2 of the lengths would be the same. And justify or prove your answer. So what I'm going to have to do is I'm going to have to find the length of all 3 sides and show that 2 of them are the same and 1 of them is different, if in fact this is an isosceles triangle. So there's a formula for the length of a line when you have points on a Cartesian plane. It is actually a rearrangement of the slope formula in a way. It is a combination of your slope formula and the Pythagorean theorem, in fact. But most people don't want to think that hard about it. Most people just want me to give them the formula. So the length of a line, so I'll put L for length. They put, in the textbook, they put D for distance, the distance from one point to another. I'm going to put L for length. I don't care what letter you use. It's just the distance or the length of this line. And the formula goes like this. The square root of x2 minus x1 squared plus y2 minus y1 squared, okay? So the difference between my x's squared plus the difference between my y's squared, and take the square root of it. So we are going to have to find the length of line AB from A to B. We are going to have to find the length of B to C, that line. And I'm not going to have space, I'll put it down here. We're also going to have to find the length from A to C. Once we find the length of each one, we can then identify what kind of triangle we have. So from A to B, and I'm going to follow this. So from A to B, again, it doesn't matter which one you label 1 and which one you label 2. What you can't do, and what a lot of people do, is they go x2 minus x1. Well, that's not an x, that's a y. But a lot of people will do 2 minus negative 1 and then 0 minus 3. But you're subtracting a y and an x, and you can't because those are different things, right? So from A to B, x2 minus x1. So if this is my x2, that's 3, minus negative 1. So 3 minus negative 1 squared plus y2 minus y1. Well, I was using this as 0.2, so 0 minus 2 squared. So this is 3 plus 1, which is 4, squared, which is 16. 0 take away 2 is negative 2 squared, which is 4. So this is actually the square root of 20. You don't even have to evaluate it, to be honest with you. You can just leave it like that. You don't have to simplify it, because I mean, technically you could simplify this down to 2 root 5. You don't even need to. Just leave it as root 20. It's easy. Now, from B to C, from B to C. So from B to C. So again, I've labeled this as 1, so we'll label this 2. So y2 minus y1. So 0 minus negative 4 squared plus, again, if this is 2, x2. Oh, I did my y's first. It doesn't matter whether you do your y's first or your x's first, by the way. You can flip those. It's fine. So 3 minus 1 squared. I'm just used to doing y's first and x's second because of the slope formula. And it doesn't matter because you're adding, the order doesn't matter. So 0 take away negative 4, that's 4 squared, that's 16. 3 take away 1 is 2, squared is 4. So this is the square root of 20. So a lot of people will go, well, look, I just proved it's an isosceles triangle because those two lengths are the same. I'm done. But you're not technically, because what you've proven is it's not scalene, because scalene would be none of the sides are the same length. You've proven that at least 2 of them are the same. So at this point, this could either be an isosceles triangle or an equilateral triangle. To prove which of those it is, I still have to find the length from A to C. So again, I'm going to do that formula, x2 minus x1 and y2 minus y1. And again, I have this one labeled 1 already. So x2 minus x1. So there's my x2, there's my x1. So negative 1 take away 1 squared plus y2 minus y1. So 2 take away negative 4. And watch your signs because that can screw you up. So negative 1 take away 1 is negative 2. Negative 2 squared is 4. And right now it's starting to look like it's an equilateral triangle because I got a 4 there and a 4 there and a 4. There could be. But 2 take away negative 4 is actually 6. Squared is 36. So this is actually the square root of 40. So I have 2 sides that are the same. And hopefully you can see that down there. That's the square root of 40. So 2 sides are root 20. 1 side is root 40. So this is an isosceles triangle. We're gonna leave it at that for now. There's still 2 other examples I want to do, but I'm going to do those another day. That's enough for one day. I'm going to give you a few practice questions to do. Not very many, just a few. And that's it. Okay, that's all we're going to do today. So have a good day.